Hello folks, and welcome back. Today we're going to be covering a simpler way to deal with polynomial division. We call this way synthetic division. So let's go ahead and show you what the steps are. One of the key things to note is synthetic division only works when we're looking at this as x minus k. Our first step when we're doing synthetic division is we're going to put k in a box to the far left. Now looking at our example, we have x plus 2, meaning we have to convert this into a minus. X plus 2 is the same thing as x minus a negative 2. So this means that k is going to be negative 2. So we're going to put k, or negative 2, in a box in our top left. Step 2 is going to be write down all of the coefficients. So what we're going to do, we're going to take x cubed. Our coefficient for that is 1. Negative 14x squared, our coefficient is negative 14. 51 will be our next coefficient, and minus 54. We're going to draw a line a little bit below this, because we're going to need some space down here. Step 3, we're going to bring down the first coefficient. So we're going to take 1, we're going to bring it down here. Step 4 is multiply that by k. So k in this case is negative 2. We're going to multiply 1 by negative 2. We're left with negative 2. We're going to bring it over to here. Step 5 is we're going to add that number to the next coefficient. So now we have negative 14 plus a negative 2, and that'll give us negative 16. What we're going to do now is we're going to repeat steps 4 and 5 until we've done this for every coefficient. So we have a negative 16. We're going to multiply that by negative 2. We're going to get negative 2 times negative 16 is positive 32. We're going to write that down here. Add those two together. So we're going to have 83. We're going to multiply 83 by negative 2. Let's pull out our calculators. 83 times negative 2 is going to give us negative 166. We're going to add those two numbers together, so negative 54 plus a negative 166. That's going to give us a negative 220. So what we're doing here with synthetic division is we're just doing division, but we're leaving out the variables. What this means is our last number here is going to be our remainder. So this number is going to be our remainder. And this is going to be what's left over. So that means that 83 is going to be left over. We'll have a minus 16, and we're going to keep going up by x in 1 degree. So the next one's going to have 1x. So we'll have positive 83, we'll have negative 16x, and then we'll have 1x, but this time we bring up our power, so it's x squared. The other way you think about this is we started off with x cubed. We're just going to reduce that power by 1. So we'll have x squared in the first category. We'll have x by the negative 16. Then we'll have 0 x's by the 83 with a remainder of negative 220. Right, let's do a couple more practice problems here. First one we have is negative x, or positive x cubed, minus 57x plus 56 divided by x minus 7. Now notice here, we don't have a quadratic term. What does that mean? It means we have 0x squared, so we're going to put in a 0 for that term. our first step is going to be put k in a box. We have x minus 7. So we're looking for x minus k. We have x minus 7, so k is going to be 7. Put 7 up in a box here, and we'll write down our coefficients. Our x cubed coefficient is 1. Our x squared is 0. Our x is negative 57. And our constant term is positive 56. We're going to draw our line and bring down our first coefficient. So we'll have 1 comes down here. We're going to multiply that by our number in the box, or k, so 7 times 1 is going to be 7. Add 0 and 7 together to get 7. We're going to multiply those two together, so 7 times 7 will give us 49. Now we have negative 57 plus 49. Let's go to our calculators. That's going to give us negative 8. We're going to multiply 7 by negative 8 to get negative 56. Or, when we add 56 and negative 56 together, our remainder is going to be 0. So remember, our last number's the remainder. And then we take our degree of x and we bump it down 1. So our answer here is going to be 1x squared, because we bumped this down from x cubed, plus 7. We're going to decrease by 1 in x, 7x minus 8. Or if you want to think about it the other way, we start with negative 8 being our constant, and we go up 1 power of x. So we have negative 8, we have 7x, and we have 1x squared with a remainder of 0. Now let's do one more here. We have x cubed minus 4x squared plus 6x minus 4 divided by x minus 2. So step 1, we have x minus 2, so k is going to be positive 2. We're going to write that up here. We're going to take our coefficients. So we start with 1, negative 4, 6, and negative 4. We're going to draw our line down here. First step, bring the first coefficient down, so we get 1. We're going to multiply that by k, so 2 times 1 is going to give us 2. Add those together, we're going to get negative 2. So 2 times negative 2 is going to give us negative 4. Add 6 and negative 4 together to get 2. 2 times 2 is going to give us 4, and we'll end up with 0. So we have a remainder of 0. Our next term is going to be the constant, positive 2. Our next term is going to have 1 more x, so 2x. And then our last term is going to have 1 more power of x than that. So we have x squared minus 2x plus 2 is going to be our answer. Now this becomes very important here. We have synthetic division is much easier than polynomial long division, but we can only use it when we're dividing by a x minus h or x minus k expression. We can't use it if we have 2x plus 3. We can't use it if we have x squared. It has to be x minus a number. Now let's have you all try a couple. What is our answer going to be when we divide x cubed minus 3x squared minus 5x minus 25 by x minus 5? Go ahead and try it. So what are we going to do? Well, we're going to put a 5 in the box here. We're going to put our coefficients, so that'll be 1, negative 3, negative 5, and negative 25. And then we're going to bring the first coefficient down, multiply it by 5. Negative 3 plus 5 is going to give us 2. We're going to multiply 5 by 2 to get 10. Add negative 5 and 10 together. Then we're going to multiply 5 by 5 to get 25 and end up with no remainder. So our answer is going to be, we start with x cubed, so we're going to bring it down 1 degree. So we'll have 1x squared plus 2. We bring the degree from x squared down to x plus 5. So our answer is x squared plus 2x plus 5. Let's have you try this one, but be very careful. We have no x cubed term and no x term. So remember to put your zeros in for those. Go ahead and try these. For this one, we have x plus 2, so that's the same thing as x minus a negative 2. So we're going to throw a negative 2 in our box, and our coefficients will be 1. We have no x cubed terms, so that'll be 0. We have 6x squared. We have 0 x's, and we have negative 27. Now we're going to add these together. We bring down the first coefficient. Negative 2 times 1 is going to give us negative 2. Add those together to get negative 2. Negative 2 times negative 2 is going to be positive 4, so those will add together to 10. 10 times negative 2 is going to give us negative 20. And so negative 20 times 2 is going to give us 40, meaning our solution is going to be 40 minus 27. That's going to be 13. So this is our remainder. We have a remainder of 13, and we move back. So negative 20 is going to be our constant. We're going to have 10 x's because we keep going up in x. We're going to have minus 2 x squareds, and we're going to have 1 x cubed. Of course, we can't forget our remainder is going to be 13. So this is our answer, x cubed minus 2x squared plus 10x minus 20, with a remainder of 13. Now, just like with polynomial long division, the remainder is actually an important part of synthetic division. Specifically, we actually have a remainder theorem about this. The remainder theorem says that if you're dividing some polynomial by x minus k, like we've been doing with synthetic division, then the remainder will be equal to the function value at the point k. This is important because if you evaluate the polynomial at that point and you get 0, that means that x minus k is a factor of the polynomial. Let's break down what that means. This means is we can divide any number k, and if we get a remainder of 0, that means that x minus k is a factor of p of x. Let's go ahead and put this to use. We're going to try to determine if x minus 3 is a factor of this function. How are we going to do that? Well, we're going to synthetically divide and see what our remainder is. So we have a minus 3, meaning we're going to flip the sign. We're dividing by a positive 3. Our coefficients are going to be 1, 7, and negative 30. Let's do our synthetic division. Bring down the first number. 1 times 3 is going to give us 3. 7 plus 3 is going to give us 10. And 3 times 10 is going to give us positive 30. So we'll end up with 1, 10, and 0. Our remainder is 0, meaning that this is a function, or this is a factor of this function. So the answer is yes. X minus 3 is a factor. Let's have you try one of these as well. So this time we're going to use synthetic division to determine p of negative 2 for x. Now be very careful, we have no constant term here. So we're going to have to include a 0 at the end. And how do we do this? Well, to determine p of negative 2, that's the same thing as dividing by x minus a negative 2. So go ahead and try to synthetically divide this. For this, we're going to put negative 2 in our box, because we're looking for p of negative 2, and we'll put the polynomial in. Our coefficients are 1, 4x squared, 4x, and we have no constant. And we're going to go and bring down the first one. 1 times negative 2 is going to give us negative 2. We're going to have 4 plus a negative 2 is going to give us a positive 2. We're going to have 2 times negative 2, or negative 4. 4 times negative 4, or 4 plus negative 4 is going to be 0. So we'll end up with 0 and 0. So our remainder is 0, meaning that p of negative 2 is this remainder. So p of negative 2 is going to be equal to 0. And that also means that x minus a negative 2 is a factor. All right, folks, that is the basics of synthetic division. Go ahead and try the homework.